Hello, Anton. How's it going? Good morning, good evening, good afternoon.
Yep, good time of the day. Thank you for
Cool.
joining.
So,
Arthur, it's your first time on this workshop.
it
Matthew
is
was met before.
excited to be here.
Yeah, and thank you for stepping up for the task. And I'm very happy to have you here. And yeah, without further ado, let's start talking about why optimize Kubernetes and how to do that correctly.
Cool. So, Anton, what are we going to do today? You want to run us quickly through the agenda for today's session, and then we'll, guess, dive straight into it.
Right. Well, this is a workshop. We really want you to participate. That means to do anything that we do. We want you to be able to do the same for your own clusters. We will be using PerfectScale because that's basically what we do, right? We're building PerfectScale. We will be using PerfectScale as an example of how to use modern tooling in order to keep your clusters reliable and cost optimized. So the first thing we will show you how to do is how to set up a PerfectScale account. We really encourage you to do that. Set up an account, connect a cluster of your own so you can see everything that we do, you can do on your own cluster too. Then we'll go over the optimization trends for Kubernetes. We'll explain the reasoning behind why you need to optimize and what it means to keep your clusters optimized. Then we'll show how to connect your first cluster to PerfectScale. And then we'll dive into the optimization process as we know how to do it. So we'll go over the workload level optimization, node level optimization, how to set up alerting, and how to analyze the trends to make sure you're on the right path. All along the workshop, we do encourage you to send us your questions in Q&A. We will be looking at them. We'll make sure to answer all of the questions if we have time, and if there are some questions left after the workshop is over, we'll get back to you with the answers. So definitely send us all of your questions, feedback, comments. We're here for you. And with that, let's talk about how to set up an account. Okay, let me go to the PerfectScale website.
Yeah, and I think, Anton, you want to share your screen for us so we could all follow you?
You're not seeing my screen. Okay. Oh, okay. I think I paused it. And now, okay. Can you see my screen now? Arthur, can you see my screen?
Not yet, not on my end. Yes, all right.
Okay. So now you can see my screen. Wonderful.
Yes.
Okay. So
So as I go ahead, yeah.
one thing probably to mention is that on our website, you now see we're PerfectScale by Doit. Exciting news, PerfectScale has been acquired by Doit, the international FinOps and cloud tooling company. But let's not get stuck on that. And instead, let's talk about how to set up an account at PerfectScale. So PerfectScale is a Kubernetes optimization tool. We'll show you in a minute what it allows you to do. But first thing first, we do encourage you to set up an account. Basically, all you need to do is go to www.perfectscale.io, click on Get Started. And of course, this is not something that's going to happen. This happens to me because I'm already logged in. So let me log out and show you what happens when you click on Get Started. And of course, this will show you this account. You need to input your company email. Gmail or Yahoo Mail won't do. So you definitely need something that's a company email or something that looks like a company email. Your
Of
name,
course,
your
if you,
yeah,
yeah, and of course, if you have like a company, a Gmail account or a Google account or a Microsoft account, you can just click at the buttons below and you will get the single sign-on working for you.
yeah, definitely. And then once you do that, we're sending a verification email. It will take a couple of minutes for it to arrive. And once you verify the email, you can log into PerfectScale. So please go ahead, set up an account. We'll show you how to connect a cluster in a minute. And in the meantime, Arthur, why don't you walk us through the Kubernetes optimization trends and explain why we need to optimize?
Sure thing. So yeah, so while I'm doing the three slides, feel free again, as Anton mentioned, go in your other tab in the browser and just log into the PerfectScale website, create an account and sign up. As the next steps are going to be like technical hands-on steps, so feel free later on to follow along. So of course, we're doing optimization and workload optimization and cluster optimization for Kubernetes for quite a while now with PerfectScale, and we've seen a lot of clusters. And as part of the clusters that we've seen, again, like we definitely see a lot of workloads being under optimized, right? So essentially, a lot of the clusters and a lot of the workloads that we see across the different accounts that we've been experiencing for the past time are under optimized, right? So basically, I see a lot of waste in the workloads themselves. And that's leading to a lot of inefficiency in autoscaling, right? Essentially, if you know how Kubernetes autoscaling works, basically that follows the requests that are being generated by the workloads in Kubernetes. And of course, if they are inefficient, if they are not set correctly, you will see a lot of nodes being over provisions. And this, obviously goes down to cluster autoscaler, Karpenter, NAP, or whatever autoscalers that you would have with your own cloud provider. But also you see a lot of, if you're into saving the environment, you're also running a lot of redundant CO2, so that's also not nice. So yeah, but one thing that we do constantly hear about optimizing workloads is, hey, if I want to optimize my workloads, that usually means I'm going to provision less resources for my applications. Now, if I'm provisioning my applications with less resources, that sort of leads us to the next point of we have now not enough resources, right? So we basically have under-provisioned workloads, and that introduces a lot of resiliency risks into the workloads. And of course, we do not want to be alerted or our phone to be phoning to be ringing in the middle of the night, waking us up to handle CPU issues or CPU throttling or out of memory running for specific workloads. That kind of not fun at all, especially if you're an SRE. So under-optimized workloads are not fun and you waste money. But on the flip side of it, we do see a lot of resiliency, even for the clusters that are under-optimized, we do see a lot of resiliency issues that are not addressed on other workloads, right? So basically, you have a lot of workloads on normal clusters. Some of them are over-provisioned, some of them are under-provisioned, and essentially you see like a nice combination, like in each cluster, you see a nice combination of too much expenditure and also, on the flip side, a lot of resiliency issues not being addressed, and SREs getting these calls in the middle of the night, which are not fun at all.
So basically, even if you're wasting lots of money, it doesn't mean you're being reliable.
Exactly. So in order to address that, usually you go through this sort of vicious cycle of optimization, right? You analyze the situation, you look in the cluster, you basically observe all the workloads that you have within the cluster. You see the patterns or you try to find patterns in CPU usage. You might have some sort of regular cadence where, maybe on the weekdays you have a lot of loads and then on the weekends you have less loads. So we try to identify the seasonality in your workloads. Then you take this period of time to plan for the optimization. Again, like you have lots of workloads, each of them requires resetting the resource requests. This takes time for planning. You execute on that plan. You verify that all works correctly, right? But then again, a month has passed since the point you started to analyze. You realize, hey, now my pattern has changed and now I'm again under optimized. So you're sort of stuck in this vicious cycle of constant optimization where you're never optimized. You always have some resources that are misbehaving, other resources that are requesting too much resources, other workloads that are requesting too much resources. Then you have your Karpenter provisioning more and more nodes, and you're sort of not enjoying at all this situation.
Yeah, and that's basically why most teams out there don't optimize, or at least initially don't optimize unless they realize they're burning a lot of money. So, as Arthur correctly explained in this overview, there are risks that are related to over-provisioning, just as there are risks that are related to under-provisioning. So diving a bit deeper into the technical implementation of this, so if you're running anything on Kubernetes and you've been doing this for a while, you probably understand how Kubernetes defines this, right? So for every workload, every pod, every container actually that runs on Kubernetes, there are two definitions regarding the resource allocations, right? We can define the requests and the limits, and we can define those for different types of resources, but the most basic ones are CPU and memory, right? So the meaning of that for CPU and memory may be sometimes different, sometimes it's similar. So let's go over this table and understand what the meaning is, what the impact is. So basically, when we're over provisioning the requests for either memory or CPU, we're wasting money, right? So we've requested, for example, 2 gigabytes of memory or 2 cores of CPU, and we're hardly using a quarter of that. That means all of the rest is allocated. We're paying the cloud provider for that, or maybe we're not using that capacity for other workloads, and that means we're just wasting resources, right? If we are under provisioning requests, then of course we start getting reliability and resilience issues because we've requested too little, and then our container, our software starts running into these bottlenecks where it doesn't have enough operating memory in order to run. So that means it starts crashing on out of memory, or it doesn't have enough CPU and it gets throttled. When we over provision limits, that means we lack a cutoff switch. That means that one of our workloads can theoretically take over all of the node's resources and strangle other workloads running on the same node. When we under provision the limits, again, there's a cutoff switch that's not in its correct place, and our workloads get strangled by those limits. We can opt into not defining anything, and that's what many organizations start with. But then, of course, this breaks the entire orchestration because the Kubernetes scheduler has no idea where to put containers which don't have any requests or limits defined. Undefined requests are bad. Undefined limits for memory are also bad because there is no cutoff switch. The CPU limits is a case that's separate from all the rest. We basically by default do recommend not to set CPU limits, and we have a blog explaining that on our website, and there are other blogs you can find on the internet. In general, the best practice is not to set the CPU limit in Kubernetes and let the Linux kernel scheduler take care of that. But there are some specific situations where you do want to define CPU limits, and that's why, for example, in PerfectScale, we're flexible around that. The default is undefined CPU limits, but if you want to keep them in place, then definitely do that for specific workloads, for specific environments, or whatever. And of course, all of these have an impact on nodes, not only on workloads. So if we over provision resources, that means we need to get larger nodes, and that impacts budget. And if we keep stuff under provisioned or not defined, then we probably will provision nodes that are too small, and that will impact our reliability. And of course, not a good thing to have too. Okay.
So,
That
Anton, question from the crowd before we
Yep.
jump into the actual hands-on practice. So, Randy asks about using templates or standards for driving optimization in the clusters. Like, how can we, could we use some templates to get us to help us with optimizing the clusters, or what do you think? What are your thoughts around that?
Well, Randy, first of all, thank you for your question. So basically, when we talk about optimizing workloads on Kubernetes clusters, we're talking about setting the resource allocation correctly in order to promise the optimal reliability at the lowest possible price, right? That means templates could help. And actually, some organizations, because optimization is a time-consuming task, they opt into setting, standard resource allocations based on the type of workload. So you can say, I know that I have some Java containers, and they usually use something like, I don't know, 4 gigabytes of memory and 2 cores of CPU. So if this is a Java container, let's have a policy in the cluster to always set it to that. And then we have some Golang containers, and those probably will need less memory and less CPU because Go is more optimal in its resource usage. So yes, you could use some templates according to what you know about your workloads, but it will never be as efficient, as effective, and as cost effective as actually measuring your workload's resource consumption and setting the allocations according to that. And that's what we are suggesting.
Cool, thank you.
Okay, so let's see all of this in action. So we're assuming you've already set up your PerfectScale account. And if you've done that, then you should get a screen that looks something like that. Let me log into my account.
You're using the nice single sign-on button.
Yep. So this is the single sign-on experience that we have in the platform. So when you first enter PerfectScale, you will see this overview page. It will look differently for you because you still don't have any clusters connected. So instead of these lines here, you will have one blue button just like here that will say add a cluster. I'll show you how to add a cluster. So when you click on add a cluster, basically what you need to do is you need to add our Helm repo to the list of your Helm repositories. So you copy that to clipboard and you go to your, oh, sorry, not that. Where is it? Okay, right here. Okay. Probably, okay. So you go to your console and you paste it here. Okay, PerfectScale has been added to your repositories, and you go back to your PerfectScale screen. You give your cluster a name. Let's say we will call it workshop. You can set your default optimization policy. We recommend starting out with balanced, but if you know that your cluster needs more headroom by default, or maybe you want to be focused on maximum savings, then definitely choose whatever you feel is correct for you. Now, a few words about which cluster to choose. If you have an access, we do heartily recommend you to connect your organization's dev or testing cluster, and then you'll get all of the insights for that, and you can evaluate those insights and use that data, and then you can also understand how to do that for your production cluster. By default, we're not doing any changes to your cluster, and our agent that we're going to install in a minute is very resource efficient, so it definitely doesn't take any toll on your cluster. But if you don't have an access, or if you're hesitant about connecting your actual development or staging or testing cluster, then definitely you can go ahead and connect even K3D or Minikube cluster that's running on your laptop. Just make sure you have some workloads on it in order to understand the optimization process. So once you've given your cluster a name and chosen an optimization policy, you click on Generate Secret. This gives you the Helm upgrade -- install command. You copy that to clipboard. You go back to your console. You paste it here. This installs our agent. As I said, a very small, lightweight pod, and a cube state metrics instance that allows us to pull the necessary metrics from your workloads. And once that is done, your cluster is connected to PerfectScale. So we go back to our PerfectScale interface, click on Finish and Close. The cluster is already here. Just as the interface says, you will need to allow us some time to collect the data for your cluster. So we'll come back to that cluster later. And right now, I'll give the mic back to you, Arthur, so you can walk us through the overview page to explain what we see here and what are the data points here, how can they help us in our optimization effort.
Awesome. Cool. Thank you, Anton. So one of the questions, I'm going to start off by addressing one of the questions in the chat here, which is what clouds do we support? I assume that's what it means. So it supports basically all major clouds, AWS, GCP, and Azure. And also you can install your own on-prem clusters with OpenShift or other providers that you deploy on-prem. So once you add a cluster, you basically get this nice overview page that shows you a summary of what's happening in your environment. And of course, if you have multiple clusters, that's one of the main things that you would like to see is the summary of what's happening in your whole environment. So at the top, you can see, in fact, two pieces of information that are critical. The first is the resiliency in the whole environment. So in this case, we have a few clusters and all of them together have 13 high-level risks. But on the other side of the screen, you can see a summary of the financial information that's happening in this environment. What Anton is highlighting here is the impact tracker that shows how much money this actually saved in the environment. And in the middle, you can see the total cost in the last month, in the selected time frame, and the recommended cost for this environment, meaning what would happen if you apply all the recommendations that we have for this environment, right? And then a summary of the potential savings monthly and annually. And if you look at optimization, right? So basically there are two sides that you would like to optimize, right? Like Anton is gonna address the resiliency risks in the next few minutes. But before that, when we say optimize, right? This basically goes down into wasted resources, right? Meaning you requested too many resources for your workloads, but also when you provision nodes and they are not requested, this leads to idle nodes, right? So this screen, in fact, shows you the two aspects of over-provisioned resources, where you have a summary of the waste of your pods, and also the summary of the idle costs for the nodes that are provisioned in this environment. And again, you can see in the table also the summary per cluster and the status for the automation of each of them. And Anton is going to touch on automation in a bit.
Okay, thank you. So this was an overview. This shows you the information regarding all of the clusters. And of course, one more thing I think worth mentioning here is that the pricing information by default, we're just taking the shelf prices that the cloud providers are publishing. We do work with the current information from AWS, and also starting to work with the same type of information from Azure. That includes all of your cloud discounts. So in this way, we can show you the actual pricing that you're paying for your instances. Now, of course, you can also run PerfectScale on on-prem clusters, and optimization is relevant for on-prem clusters too, because they're usually shared by multiple teams, and you do want to make sure that any specific team is not using all of the resources in the cluster. So for on-prem clusters, where you don't get the pricing information from a cloud provider, you can definitely set your own pricing, and there is a configuration for a cluster that can be defined for that. Okay, so once we looked at the overview, we can dive into a specific cluster. We'll go to the first one here, which is a cluster running on AWS with its pricing information getting pulled from the cloud provider based on the cloud discounts that you're getting. When we click on it, this takes us to the next view, which is called PodFit. This is where we're actually optimizing the workloads, getting their actual resource utilization data and the recommendations that PerfectScale has generated for them. Now, as Arthur already said, we do realize that most folks out there usually tend to err on the side of over-provisioning, because they don't want to under-provision, because nobody likes to be woken up at night because their pod is failing, because it doesn't have enough memory, or because there is a very high latency, because stuff is getting throttled because it doesn't have enough CPU, right? So folks do over-provision, and that's why we're also hesitant about reducing costs, because that means reducing resources, and that means reducing reliability. That's why we are saying what we do, we provide responsible cost optimization, letting you focus on reliability first, letting you focus on reliability risks first, and only after you've taken care of all of the reliability risks, only then you have the peace of mind necessary in order to start optimizing for cost. So the first thing we suggest to do is looking at the workloads that are at very high risk, right? And that's what we see here. We can see that the high risk here is, we have 7 workloads at high risks. Let's look at the first one here and see what the risk there is. So we can see the total risk here is 1, and that's because this specific workload is restarting a lot. Now, this could be related to its resource utilization, or maybe could be related also to the workload itself, to the container itself not being reliable enough. Maybe it has some bugs in it. Now, if we look specifically at this one, it looks like its utilization is under its current limit. Okay, we can see that its 100th percentile is still under the limit, and its 95th percentile is under its current request. So memory-wise, it's okay. Also CPU-wise, it's okay. So it looks like this one is failing for a reason not relevant to resource allocation. So let's look at another one. Maybe let's look at Prometheus. See that we have some risk here. Okay, this is also restarting, and also probably not because of the resources. Okay, that's a good thing. That means that all of the resource-based risks have been taken care of, or at least most of them. And that makes sense, because the clusters we're looking at have been optimized for some time already. Now let's look at this one. So we can see that we have a lot of restarts here. And there is also a risk because the memory limit for this workload is not set. So PerfectScale is recommending to set the memory limit a little bit higher than its 100th percentile. And of course, we still don't know why this is restarting. and that will need some digging into it. So once you've taken care of all of the reliability risks and applied all of the recommendations that PerfectScale recommended, and we can see that actually for some of those, we can see that the PerfectScale recommends to increase the cost in order to promise the resilience. And for example, here you can see that we are recommending to set a limit for memory too, okay? Once we've taken care of all of the high-risk workloads.
And maybe you want to go into the recommendations tab and show us a little bit the recommendations themselves in the main screen.
Yeah, I think we'll go over the recommendations when we start talking about the waste, okay? If it's fine. Okay, so let's look at all of the workloads. So once we've taken care of all of the risk, we can start looking at waste, because again, our goal here is to optimize the cost. Now that, let's say, we've taken care of all of the risk, we've applied the recommendations, and we'll talk about how to apply the recommendations in a second, we want to take care of waste, right? So we can sort the workloads based on waste, and we can see that the most wasteful workload here is wasting $144 a month. Okay, let's see why that happens. So basically what we see here is that this doesn't have CPU request set, this doesn't have memory request set, and this doesn't have a memory limit set. So basically what happens here is we're getting stuff allocated. Why does it say that it's not set? That's interesting. Oh, because there's another container here. Okay, the risk here, you'll notice, so many pods in Kubernetes, of course, have multiple containers. So the risk here relate to the ClickHouse lock container, which doesn't have resources set, but the actual waste comes from the main container here, the ClickHouse pod. We can see that at its 100th percentile, it's already hitting its current memory limit. So here, PerfectScale is suggesting to take the limit higher to 73.728, right? Now, all of the waste here comes from CPU, actually. Its current CPU request is at 14,000, right? But the actual utilization at its 99.9th percentile only reaches 1,500. But of course, the 99.9 utilization isn't interesting for requests, because what we're seeing that at 95th percentile, it's only using 1,817. So what we're saying here, a request of 4,781 will be definitely enough for most of the cases. So set the request at that. Don't set a limit to make sure you're not crashing even when it goes up to here. But by setting the request much lower than it currently is, you can save a lot of money on this specific workload. Now that's why we're giving this recommendation. This recommendation can be seen here. We're also showing you the YAML snippet in order to apply the recommendation, so that you can easily just take this YAML snippet, put it into your YAML wherever it's stored in Git, or maybe in your Helm chart. You can also, if you don't want to apply it directly, you can create a task. We have a Jira integration that allows you to create a task for the specific engineer that's responsible for that. And that's how you do optimization manually until you learn to trust the system and decide to turn on the automation. Arthur, do we have any questions related to PodFit?
Nothing specific coming from the chat, but I think one of the things that you highlighted there is the recommendations themselves. And if you click on the zoom in window again, this window that you showed be called the zoom in window, on the right-hand side, you'll be able to see the actual YAML snippet. with the recommendations. You can simply apply that and paste it into your spec. And again, if you have GitOps, you can just add that into your GitOps flow. But if you want to see a summary of the workloads, if you close the window again
Yeah.
and click on the recommendations tab that I wanted to show earlier on the next to the HPA, not this one, next to the HPA. Now the HPA is selected. Yes, on the left two labels and policies. Sorry.
Oh, okay, this one.
Yes, yes, perfect. So here you basically can see all the recommendations for the workloads and the specific changes that we recommend you to apply. Which is anything to do. Again, like you can go workload by workload and use this in order to optimize the workloads one by one manually. And Ant will discuss automation, which is definitely a key point here. Again, like you can do this manually. And I think one of the questions in the chat was like, hey, can we do this by ourselves without PerfectScale? Of course you can. Hey, there's not too much magic here. Obviously we continuously monitor the system and we have our own intelligence into how we apply recommendations. But again, in essence, you can apply, can open any monitoring system, see the actual usage, apply common sense for your specific use cases per workload to figure out the specific optimization that you would like to apply per workload. And of course, here you can just, select the optimization policy, whether it's balanced, if it's production system, so you probably want to have some sort of an extra headroom setting applied to the cluster, and basically apply all the recommendations one by one, or again use a tool such as PerfectScale in order to apply them, in order to get the recommendations automatically, or enable automation, which, as I mentioned already, Ant will touch upon in a second. So this is the pod fit view. So like when you're optimized, there are essentially two views of the world that you should be constantly looking at. The first is this one where you look into workloads themselves and optimize the workloads. And of course, all the cluster auto-scaling mechanisms react to the settings that you have within here, within the workloads themselves. But if you go to Introfit, you would be able to see the other side of the world, right? Where you look at the actual resources that are being provisioned by the cloud provider.
Yeah, that's where the actual cost is, and we'll go there in a second. I just want to summarize this for the audience. So the optimization flow, as we suggested, is first of all take care of all the under-provisioned workloads, take care of all the risks, and once you've done that, you start looking at your most wasteful workloads and applying the recommendations for those. And once you do that, right, it's time to look at Infrafit and understand where those costs come from. Now, Arthur will give us an overview of Infrafit and how to understand where the cost comes from, what nodes are connected to a cluster. But there are some questions here, Arthur, that I'd like to answer. So Malikarjun, is asking, how do you collect the usage on the cluster? Okay, 3 questions, not 1. So the usage is collected through kubestate metrics, the open source Kubernetes metrics collection component. And we have our own agent that's very resource efficient, written in Golang. The load is very minimal. We have the actual recommendations for its resource allocations somewhere in the documentation. I don't remember them by right now. And it's not a daemon set. It's just a single pod. And do you have an architecture diagram which shows the data stats flow between cluster and PerfectScale? Yes, somewhere on the documentation on the website. We don't want to show it now because, again, this workshop is not about specifically PerfectScale. So we'll definitely give you a demo if you want one. This is about how to keep your clusters optimized, whether you're using PerfectScale or not. Okay. done with that question. And Arthur, the stage is yours.
Awesome. Cool. So again, we are optimizing our workloads, but in fact, we pay to the cloud provider for the nodes that are being provisioned to run our Kubernetes workloads, right? So the way to think about optimization, I think this screen sort of illustrates this really well. So again, think of the number of nodes you have running in your clusters, and those nodes run in workloads, and then each workload uses some amount of resources, right? So if you think about the resources that you use, you are using CPU and memory, which are the most expensive workloads within your cluster. I'm not touching GPU specifically. Of course, GPUs are way more expensive than anything else in the cloud today, but that's a topic of its own that deserves a session of its own. Shout out to Brendan to, I guess, our next webinar.
Yeah.
So going back to CPU and memory. So here we basically have a nice view that summarizes all the data for your cloud resources. So here on the left-hand side, a nice little widget, you see the expenditure per node group in your specific cluster. And again, you can go cluster by cluster. You have the nice little cluster selector at the top. And you can see how much money you are actually spending per node group. But also, on top of that, like the more important, more interesting part is like, hey, how can I optimize? So if you hover on top of the CPU or memory widgets, you'll be able to see how many cores are actually allocated, meaning these are nodes that are actually being provisioned by the cloud provider. So in this case, in that specific point in time, we had 281 cores being provisioned by the cloud provider, which we pay for. And of course, you have Karpenter, it scales up, scales down the resources. So you see the amount of resources being allocated and provisioned by the cloud provider, but also in the same view, you can see how many resources are being requested, right? So basically you have a nice summary that takes into account all the stateful sets, deployments, daemon sets, pods, jobs, you name it, that actually request resources that the cluster autoscaler reacts to, and also how many resources are being used by these workloads. So I can see, again, to summarize this point, you can see how much the cloud actually allocates, how much are being requested, and how much of them are actually being used. And this highlights really well where, the points where we can optimize, right? Again, the black bar here is the nodes that are being provisioned and not being used. These are idle, idle resources. Then you have the requests that are not being used. And then you have the actual usage of the nodes. And you can see that per node group in your cluster, meaning you can actually dive into the specific node group. And again, you can, for example, pick one of them and just go into them. In this case, you have this bar that Anton is highlighting. You have, for example, 81% there are of resources of CPU and memory that are not being even requested, right? Again, like imagine you have a bunch of nodes that are being provisioned in this specific cluster and they're not even requested. So this is definitely a lot of money going to the cloud provider that is not being used at all.
We can
So
see
yeah, so
a
this is
lot of memory here is being paid for, not being used at all.
exactly. Now the cool part is that, okay, so we're seeing now the specific node group and the node types in this node group, but if you switch to the next tab, which is the workloads tab, you can see which workloads are requesting these resources and running on these node groups that are being provisioned. So you can identify the specific workloads running on the specific node groups that you can optimize. So really nice tool to basically give you a summary of what you should be, like what action items you should be taking in order to optimize these node groups.
Yeah, so basically the whole idea here, yeah, we can optimize the workloads, we can set the requests and limits correctly in order to promise the optimal reliability and the lowest possible cost, but then in the end we still have the nodes, and if the node groups are not configured well, then we will still get a lot of idle resources when the nodes are provisioned, and we optimize the workload, but not the cost. And that means we just put a lot of effort and didn't earn any money for it. Not something you want to happen. Oh, Arthur, it looks like you have a guest there.
Yeah, I guess our optimization session is so exciting that either we pull all the children to see the show or we're putting them to sleep, as you see. So we probably want to go ahead
Cool.
and
Okay.
talk about automation next.
Yeah. So actually, I want to hop ahead a little bit. So the whole idea of our optimization effort, and we'll look at our questions in a moment. The whole idea is that we start looking at our unreliable workloads, we take care of the risks. Then we start looking at our wasteful workloads and we reduce the waste by setting the requests and limits correctly. Then we look at our nodes and we make sure we utilize the nodes in the best possible manner by configuring the node groups, configuring the Karpenter node pools, you name it, right? But at the end of the day, I, as a DevOps engineer, I need to go to my manager and tell them, look, I've reduced the costs. Or maybe tell them, look, I've done all this, but the cost doesn't go down because I don't know. There could be reasons. So how do I make sure I'm still on the right track? How do I make sure my optimization effort, me going and measuring the utilization and applying the recommendations and changing the request and limits, is actually taking me where I want to be, is making me more reliable or taking my costs down? For that, we have in PerfectScale this trends tab here, which allows us to look at what happens to each one of our clusters or all of our clusters, right? And we can define the interval here. So let's go for daily interval here. And we can even sort this by workload, and we can either decide to show the idle capacity or not show the idle cost, right? And this allows us to actually look at each one of the workloads for each day or maybe each week and understand how the cost has been changing. Now, usually when we optimize, we should start seeing the costs go down, unless, of course, we have more activity in the cluster. So sometimes the cost not going down or even actually going up can be a good thing. So if we have more demand, if our product is very successful, and we're running more instances for each one of our workloads, and that requires us to run more nodes, that could be a good thing if by products of this, we're also earning more money for our services, right? So yes, the trends here are a very good indication of how well our optimization effort is going. Usually when we optimize and we look at a specific cluster, the amount of idle should be going down. The amount of money we pay for each one of the workloads should eventually go down. But of course, we need to understand the business meaning of all of this. Now, once we do see that our optimization effort is taking us in the right direction and the costs are changing as we expect them to change, it's time, of course, to say, I'm done with doing this by hand. I'm done with applying recommendations manually. I do trust this specific tool, be it PerfectScale or any other tool, and I want the tool to do this stuff for me in an automated fashion, because what do we have software for, right? And that's
In
where
order to sleep a sound like this.
Exactly. Okay, we want to go to sleep quietly, knowing that our clusters are getting optimized even when we sleep. Okay. And for that, we have PerfectScale automation. This tab here shows us all of the activities that our automation is taking. Actually, when looking at Podfit and looking at our workloads, we can show the specific workloads that are getting automated here. And we have this here, right? So these are the workloads that are getting automated. We have this nice green checkbox here that shows that this workload has been automated. And if we look at that workload, one other thing we see here, by the way, is that first of all, PerfectScale, our resource allocation recommendations are revision aware. And that's something that sets PerfectScale apart from many other solutions in the market. So we do realize that when you're working in a cloud native environment, you usually strive to do continuous delivery. And that means your workloads are changing frequently. You apply new versions, you develop new features, you fix old bugs. And with each new revision, your resource utilization for any specific container could actually change. And that means for each new revision, we do recalculate our recommendations. We don't get stuck in the past. We're always getting updated according to each new revision. We do realize that a bug can be fixed and that can take the memory utilization down, or maybe a new feature could be deployed that actually takes the utilization up. So that's why for each revision, we're showing you what the status was and what got changed between that revision and the current revision. Now, in order to see the revisions here, we can look at the revision history. Now, for this specific workload, we can also see that some of these revisions have been deployed manually, while some other revisions have been deployed by automation. What does that mean? That means that this workload is automated. That means that PerfectScale has found that a change is required in order to optimize the workload, and it has set the requests and the limits for that workload accordingly, and a new revision of a pod has started running. And you can
So a
see,
quick question. I see that the automation is enabled and active for this workload. Do I have to enable automation for all of my workloads, or how does that work?
okay, so you have full control and full granularity regarding how to apply automation. And we can see that. So the way I can show it to you here is an example.
Mm.
So this is a merge configuration. So basically, of course, we won't dive into automation implementation. That's not the topic of our workshop here. If you do want to see how automation is working, definitely schedule a demo with us, and we'll be happy to show it to you. But the idea here is you have this cluster configuration custom resource that's called cluster automation config. You can set the automation on cluster level for specific workload types. And after doing that, you can also add workload automation config, namespace automation config. So you can definitely set it for the whole of the cluster, for specific workload types, for specific workloads and specific namespaces. It can be turned on and off. Workloads can be excluded or included by label or by regex. So there is a lot of granularity there, and that gives you full control on what is automated. If for some reason you want to turn the automation off, it's very easy by just applying a label, etc., etc., etc.
Cool.
Okay, now once you have the automation on, as I showed you, you can see the automation history for any specific workload, but you can also see what happens in the whole cluster. So we have this tab here that shows us all of the automation activity that has been happening, all of the changes, like for example, for this workload here, we took the CPU request down and we took the memory limit up. So this promises us more reliability, while this reduces some of our costs. The same way here, we've taken the CPU requests down and also took the memory request down. So this automation activity here, automation action here reduced our costs, etc., etc., etc. And one more thing is, of course, we do realize that those risks that we see in resource allocation and additional risks that we also see because we're monitoring your cluster, you do want to get notified about them in real time. You don't want to wait until you log into PerfectScale to realize that your workloads are under provisioned. So we also have alerts for the risks that we're discovering. These alerts can be seen here, and you can also configure an integration that will send those alerts to wherever you're used to getting alerts, be it your Grafana, your Slack, your Teams, or whatever you like using. Okay, Arthur, do we have questions?
It looks like we addressed most of them, I think. If you folks in the crowd
No,
have
no, actually, I
more
actually did see.
questions,
I see at least 3 questions that are not answered. Okay, so Sander is asking, how can I address the automatic resource configuration for scheduled periodic tasks? The pods are doing almost nothing 80% of the time, but when a scheduled task is running, it can use a lot of resources. The automation in PS will
yes.
use resources in the meantime, and this results in scaling up. Okay, okay, I see it. So basically, this is about scheduling the scaling.
Yeah, so essentially we also support, or the system supports scheduled and cron jobs. So we realize the utilization and patterns in jobs that are constantly being scheduled, and obviously apply these recommendations on upcoming jobs. So if you have a job running, of course, there's no interruption to the running job, but in the next one, we would apply the recommendations that we observe in the previous executions of similar jobs. So like this is a very common case where you have, for example, CI build jobs or Spark jobs, for example, running part of normally scheduled pods.
And we also have maintenance windows. So basically, you can define that automation is not running all of the time, but instead it's only running at specific times of the day. So if you know that you have those spikes at a certain time of the day, you can say maybe, run the automation before the spike, or don't run it when the spike is on, whatever. So whatever fits your use case. Okay, Luke Skywalker, hello Luke, says, how do you take traffic spikes into consideration when you say measure? Let's say I'm gonna have a 150% spike in traffic this weekend because of a festival. Okay, once again, we do realize you have spikes. We usually, again, we're relying on historical data. We cannot predict the future. If you know that there is some future event happening and you want to set the resources based on whatever you predict, then definitely there's some missing step there. And that means definitely do a benchmark. So if you expect a spike, first of all, benchmark your workloads based on that expected traffic. Measure, you can use PerfectScale for that, the actual resource utilization you're going to need for that spike, and then apply those recommendations. And of course, you can also turn the automation off for that specific spike time and do this manually because you're realizing that this is an extraordinary event. Automation works best in your day-to-day operation, but for special events, definitely you also always have the option to opt out of the automation and control things in a finely tuned manner.
But another point to add to that, Anton, definitely yes. Another point to add to that is that once you have a spike, you might have resiliency issues coming up as a result of that spike. And that in fact creates resiliency indicators, which instantly trigger a scale up operation with the system, right? So again, like we definitely, want to do optimization, but resiliency is key, right? So this is what we call responsible optimization, right? So in fact, once you have resiliency issues, it's key to address them as quickly as possible and only then start optimizing for costs. So again, if you have a spike, immediately you will get an increase of resources and then continuously monitor in order to optimize the cost.
Yeah, one more thing to discuss. That's totally correct. I agree, Arthur. And one more thing is usually when your traffic is highly dynamic, you want to have horizontal autoscaling first and vertical autoscaling second. And an important thing to say is that PerfectScale fully HPA aware. We do realize whenever any workload is configured to be horizontally autoscaled, and we provide our vertical autoscaling recommendations based on that fact. Of course, there are some practices that need to be applied in order for the autoscalers not to start competing with one another. With the very basic practice is to set the cutoff for the horizontal autoscaling higher than 100%.
Okay, so it looks like we are on top of the hour, even a little bit further. Any famous last words, Anton?
Well, Kubernetes is currently at a maturity level when we do realize how to do Kubernetes, and now we need to become excellent at it. Being operationally excellent at Kubernetes means keeping your clusters optimized. It used to be a lot of hard work to do that. Now, with the tooling that we have in place, and a PerfectScale is the great example of that, it's become much easier. So if your clusters are not optimized yet, definitely start optimizing and be proud of the fact that you are practicing operational excellence.
All right.
Anton, we had some people wanting to know where they can find out more. Can you show them the link where, especially those that signed up, can book an optimization session with our team and kind of talk a little bit more about their individual use cases?
In the landing, yeah, there you go.
Where is that?
It should be in the slide
You
deck.
have a nice big button as a book a demo.
Well,
Okay.
in the slide deck, there's something where they can directly book with,
Okay.
optimization
Go,
specialists.
go back to the slide deck, right? Okay. Yeah. Thank you for reminding me that. Okay. Let's see. So yeah, first of all, you can scan this QR code and this will take you directly to scheduling a demo and an optimization session. By the way, if you've connected your cluster today, in about a week, we'll have enough data in order to start optimizing. You don't have to do that on your own, even though we've shown you how. But you can definitely call us up and we'll schedule an optimization session with you. It will be me or Eli, our CTO, or one of our other city optimization experts, and we'll go over your data and show you how to optimize whatever you're running, totally free of charge. And we also have an exciting upcoming webinar. So we're having Adam Jacob, originally the founder of Chef, one of the first and most famous infrastructure as code tools, and of course a very active open source activist. And now Adam has a new company and a new product that was launched a couple of months ago called System Initiative that promises to revolutionize the DevOps automation practices. And Adam is coming to a webinar on February 25th to tell us all about that. So if you're doing DevOps in 2025, you should definitely listen to Adam because he will probably tell you how.
I'll definitely be there. Sounds super interesting, Anton.
Okay, thanks everybody for joining. Thanks, Arthur, for with me. This was a lot of fun.
And now I guess it's time to go to bed.
Yeah, you have the software right behind you.
All right, folks. Thank you very much for joining us, and see you folks next time.
Yeah, see ya, and talk to us if you have any questions.